we can't manufacture robots in America at all. Germany and Japan are losing a lot of their capabilities to do so, / the cost of their robots are just way, way, way higher than what China can do.
Dylan Patel, the founder, CEO, and chief analyst over at SemiAnalysis.
In just a few years, he's become a leading voice in semiconductors, AI, and robotics.
He has impressively built a team of more than 30 plus researchers.
And they uncovers the raw truths of the East versus West tech race.
All 4 of these countries combined, right, are still a third of China's robot deployments.
All right, Dylan, how you doing, my man?
I'm doing well. How about yourself?
Good, thanks. Well, we had a little technical difficulty on the front end, but here we are. So, Dylan, a couple quick things before we hop into it. What prompted me to reach out, and we've never met before, so there's always a fun way to have a first conversation, was a research piece you and your team put out a few months back titled America's Missing New Labor Economy, Robotics Part 1. So we'll kind of talk a little bit about that. But more specifically, I came across a couple clips of you and really just speaking about the basically AI infrastructure, and you've had some pretty hot takes, and 2 things stood out to me. One was the level of research your team does, which is like super on the ground, very detailed, really caught my attention. So I was like, that's like impressed me a lot, because very rarely do you see that type of primary research level these days, in my opinion. And then secondly, you definitely don't mince words and have very strong perspectives on the space and across just AI infrastructure, robotics, and generally. And you generally look like you're just having fun. So I thought it'd be a fun conversation. So can you just for the kind of one semiconductor 101, can you just break down what a semiconductor is and what it works? I think people just in general take that for granted. So it'd be good to get a little background there.
Sure. So semiconductors in general are, in the most simple terms, little on-off switches. That's a transistor, right? It's a 1 or a 0. And with this, you can build any number of things, right? You can build, hey, let's add numbers together. Let's multiply numbers. Let's subtract numbers. You can build things around changing power, right? Hey, go from this voltage to this voltage, go from AC to DC, go from DC to AC, right? You can do things that basically build the entire world around us, right? So whether it's your phone, it's not just the processor there. There's a chip for the screen, and there's a chip for Bluetooth, and there's a chip for GPS, and there's a chip for every little action. And you think about, okay, that's the phone, obviously, but even your car, right? A modern day internal combustion engine has, dozens of different chips in it, right? Semiconductors in it, controlling how fast is the fuel injector pumping in fuel, right? And how much, measuring how much of the, based on the power that was outputted for that cycle of the engine, how much burnt properly and how much didn't. Do we need to increase the oxygen, or do we need to, the airflow, or do we need to increase the fuel that we jet in for the next one, right? All sorts of things around how your brakes work, how the door handles to your car work, how the key fob that lets you get into your car works, right? Everything here involves using semiconductors, little on-off switches that build the entire world around us.
Oh, so you would say they're kind of important.
Yeah, I think it's funny that one of the funny stories is that, like, after the Ukraine war started, Russia got embargoed and they couldn't access many chips from Asia and the US. And so they had a project where they started tearing apart washing machines, because there's a specific kind of chip that went into washing machines that also just happened to go into their missiles. Right. It's a very simple chip. It wasn't like that complicated, but it was like, yeah, we just don't have any of these and we need to put them in missiles.
All right. So the next thing I wanted to talk to you about was kind of how you think about the just AI infrastructure stack. So, your team kind of organizes your research by like accelerate. I'm just going to go through real quick and then you can kind of break it down for us. Accelerator industry, data center industry, AI, cloud, TCO, and wafer fab is the general categories. So just kind of help us think about how to think about the AI infra stack and how it's organized.
Yeah, I think, you can look at it two ways. I think it's easier to sort of go from the top down, which is like, okay, what do models need? Well, they need compute, right? So you have accelerators, but they also need data centers, and you also need to measure sort of the cost and power of all these things, right? How much power does a GPU consume? What networking does it require? What data center does it need to be in? What are all the infrastructure layer things regarding power, delivering power in the right format to the chip? That's one. And then you go to on the data center side, there's all these, you can break that down further, right? There's how do you do cooling? How do you do power, right? And in cooling, you can do liquid cooling, you can do air cooling, you can have evaporation towers to evaporate water to cool down the facility. You have a bunch of ACs in there, obviously CRAHs and stuff like that, to keep the data center cool because there's all these chips running, spitting out heat. You can have dry chillers in areas where there's no water, right? So there's all sorts of things that, right? And then that's on the cooling side, and then on power, there's a bunch of stuff there as well. What voltages do you use, and where do you convert? Where do you have switchgear, and where do you have transformers, and where do you have all these changes of power? So we try and track supply chain for each of these components. And then we also try and track every data center in the world by taking monthly satellite photos and looking at regulatory filings and all these things, and using a lot of AI in the process, right? So that's sort of like data center side, right? And then what goes inside the data center, like physically in terms of chips, is like accelerators, right? So there's different kinds of chips. There's generally NVIDIA's on top, but there's other folks, right? Google's got their own chip, Amazon's got their own chip, et cetera, right? AMD, there's all these different chip companies that are also trying to get in. But that's just the compute accelerator for the AI itself. But then there's other associated chips, right? When you buy an NVIDIA board from them, it actually has hundreds of other chips, right? Whether it's power chips from companies like Texas Instruments and Infineon and Renesas, right? Or it's chips related to networking, right? Or it's chips related to many other topics, right? And then within the networking stack, there's own set of companies, right? And then there's there's electrical networking, and then there's optical networking, right? So there's different supply chains for each of these things that have their own sea of dozens and dozens of companies and competitors and new technologies on every layer of the stack, right? And then you break down further to, okay, you've got all these chips, you've got all these, you've got the servers, right? There's passive components that aren't chips, right? There's boards, there's copper cables, there's optical fiber, there's lenses for the optical networking, right? Go down and down the list. There's quartz crystals, which you use, which are very funny, right? If you're crystal girly, actually, most chips require quartz crystals to, basically like the crystal will oscillate at a certain frequency, and then that's the frequency that the chip can clock at, right? Because the on and off happens at a certain rhythm. So there's crystal girlies in every semiconductor engineer, right? There's sort of, you go further down the list, right? It's like, okay, well, where's all this stuff being made, right? And what's the manufacturing process for it? And so that's how you get into fabs, right? And packaging, right? Taking a silicon wafer, which is just flat silicon, extremely flat, perfect crystalline structure, and then taking it and then doing tons of processing steps. You're adding material, you're removing material, etching, depositing, you're spinning on stuff, you're doing all these different chemical processes, thousands and thousands of steps to get to a finished wafer, which then you cut into chips and package and put into like a package. And then now that's a chip, right? That you can actually utilize once you put it on like a PCB board, motherboard, right? And so there's a whole sea of things going on there in terms of the fabs. And then we track the equipments as well, right? The equipment below that, right? Like the equipment to make the chips, because that alone is $100 billion industry each year. So then that equipment is, there's dozens of companies there, and all sorts of different technologies and all sorts of different markets, right? So we try and track each of these things. And the way we do that is sort of half the companies like technical X industry, from all the way from ASML, which is like biggest tool company, right? ASML Lam Research, people from there, all the way up to people who worked at NVIDIA, Tesla, Microsoft, right? And then like tracking the whole supply chain through. We've got half the companies like technical industry people, and then the other half is from a hedge fund background, gathering data and modeling, and sort of when we put those two together, we have these data sets in consulting, right? And sort of we there's 32 of us, and we provide market research and consulting around what, where, how much, when, etc.
Cool. So talk to me a little bit about, there's a lot to unpack there, but it was good to thank you for the overview. The news cycle, part of this is just because we have real-time information coming at us all the time, right? But it seems like there's just so many announcements every day. You can't even keep up with this, especially in the AI race or AI infrastructure race. My question to you is it actually accelerating that fast, or is that just because of the fact that we have access to like real-time data, or do you find that it is moving extremely fast across all layers of the stack and the supply chain?
Yeah, I think definitely certain layers are moving. I think humanity progress is just faster and faster, right?
Sure.
Compounding growth, right? That is like the total measured growth is clearly more each year. Even if the growth rates are slowing down or have slowed down historically, they're actually reaccelerating now. The total amount of like raw growth, just generally on a human GDP basis, even is accelerating, right? Then when you think about technological progress, yeah, it definitely feels like it's accelerating, right? Like, and I think this is on every layer of the stack, but like if you just look at models, right, AI models, the progress that we've had in the last 6 months is stupendous. And if you take, 6 months in like 2022, the progress was not anywhere near as large, right? I mean, it was still humongous progress, right? In 2022, GPT 3.5 was trained and GPT-4 started training, right? And so like, it's like those models didn't come out, right? 3.5 came out, ChatGPT came out, but GPT-4 came out February 23. But like the progress then felt incredible. But if you're really watching specific stuff on the model side, looks like it's going even faster, right? There's all these new models, there's all this new reasoning, there's all these new computer use and all these code agents and all this other stuff that you see every week. New stuff is coming out, right? Like, just like last, was it this week or last week? Google I/O happened and Google released like 4 different models, and Claude 4 was released. And there's a whole new model, and this week DeepSeek was released, right? And it's like all of these models are pushing the frontier really fast. And it's easy to say like, oh, they're all just like leapfrogging each other a little bit. But in reality, it's like, look in the last 6 months, frontier math, which is an exam that is like college, like really like college majors don't even like pass that stuff, right? In math, like they can't do all the math, in all the problems in frontier math. And the models went from, sub 4% to 70% in 6 months, right? And this is from not just OpenAI, but also Anthropic and Google and DeepSeek, right? Like all these companies, their models have skyrocketed in performance there. Same with like various software engineering benchmarks, like SWE-bench. Similar story happened there, right? In the last 6 months, it's soared in the quality that's achievable. And funnily enough, every time someone comes out with a new benchmark within 6 months, it's saturated, if you will, right? Like people have,
Sure.
the models are now like beating it, right? And it's like, how many times does this happen how many times does it need to happen until we have like something that is just like an autonomous agent? And it's like, it looks like we're heading there very quickly. So I think progress in models is incredibly fast. And then as you look down the stack, in hardware, throughout the semiconductor and data center supply chains, things are moving fast, right? Now, obviously, physical goods cannot move as fast as software, but there is still tremendous progress happening.
How do you organize the team differently maybe than some other research shops to like stay on top of it because of this, right? Because there is a lot of noise. Doesn't matter. And then there's a lot of like benchmarks, but the benchmark thing is like, okay, how useful is that actually in the real world, right? So I don't know, just kind of talk to me a little about how you think about organizing the team and research coverage in the space, because it's so dynamic and changing so quick.
Yeah, so there's generally like analysts who like are covering a specific layer of the stack, right? Like someone who works on just data center stuff, actually a couple of people, right? And they even self-organize like somewhat below that, right? On what parts of the data center. Some people who work on only power, right? Of power delivery for semiconductors. Some people work only on models, right? And actually, some people work only on adoption of AI, right? Because we're tracking how much is used where, when, tokens, like how much, et cetera, cost, right? There's people who work only on accelerators, on packaging, on fabs, right? And so there are people who work on that, and then there's more on the technical side, especially. Then there's like more general, like, hey, I cover a few of these things in a more generalist way, and I interface with the super technical people. And then, like, I guess we when we look at our Slack, there's like just channels for everything, right? Like every little topic, right? And we sort of, people see stuff, they post in there, very decentralized sort of way of organizing information. People have their specific like layer that their job is there. The model, the data that they produce, the consulting they work on is for that. But then there's just immense curiosity. So people sway out of their lane a lot, and they can see a lot more throughout the company. And then as far as like myself, I just kind of like try to read everything and hope I can cover and because the important thing here is like when you look at other firms, they're like, yeah, we cover this, right? And it's like, that's great. But what I've found is when you just cover one layer of the stack, you end up missing stuff. So when you go 2 layers lower, 2 layers higher, you end up getting a data point, which like doesn't seem significant here, but is actually very significant 2 layers down the stack. And if you're not linking and connecting the dots across the stack, you're missing stuff, right? And so, yeah, you need to talk to the cloud companies and understand their cloud software, because we have a team of people who work on AI engineering, cloud software, et cetera, to understand, hey, what's going on with the reliability of the GPU, to understand, hey, what's going on with the manufacturing process and why they're unreliable, right? And it's like you have to skip multiple levels, but this only works if you connect the dots across the stack, right? And so we try and do that, and we try and make sure people are just curious, and they target all these things, because it ends up being like a very multifaceted problem. Like you don't understand why a chip is unreliable or reliable unless you understand this cloud software, and then you understand the manufacturing process and what happened there, right? And so when you look at traditionally, people will silo very deeply, and it ends up being a problem, right?
Yeah, it's interesting. It's this whole new ecosystem, and we'll get into that because if you go trace it all the way back to the foundations of the supply chain, right? You get into rare earths and minerals and all that good stuff, which we'll get into. But what percentage of what you do is actually research versus actual kind of project-based consulting? Approximately.
I think they're the same thing, right? Like you take a consulting project and you learn a ton about a research, right? Like an area of research, right? So what it ends up being is there is some base level of like just always trying to ingest all the information.
Mm-hmm.
But then we have the data products, which end up as like a vertical or a horizontal to get out research regardless, right? So then that's part of the product, right? Is research and put it out in that product. And then there's consulting projects, right? Like, hey, help us with this design decision. Hey, help us with this chip. Hey, help us understand what our competitors are doing and what we should do. Hey, help us, decide on this investment or that investment, right? Like anything across the stack, whether it's like a technical or investment decision or strategy choice, you end up getting the project, it's revenue, you spend more time on it and you get a lot deeper, but then you come away having learned things that you can then apply elsewhere. And so that's like, you wouldn't have spent the time doing that because the opportunity cost is, there's a billion things to look into constantly, right? And so that's also a part of it, right? Is constantly research is consulting and consulting is research, right? In this instance.
Sure. But I mean, as far as your actual like data products and research reports versus doing the project-based work, is that like from a business standpoint, is it roughly equal? Is it always changing?
I think it's always changing, right? Because
Okay.
some weeks people are working only on data products, and then some weeks different people are working only on consulting projects, right? And they're
Okay.
context switching back and forth, right? I think because they're so synergistic, though, right? Like you can just like the same work could go apply to both, right? Like, and that's what's so making sure you understand everything and that's happening and have a really up to date view of currently what's happening, whether it's what's happening to this data center here or this fab there or this chip's production timelines and yields and all these different things. It's kind of that's the base level, and that always happens, right? That's every day. You got to keep in track.
Sure.
And then where do you choose to dive even deeper? And for data products, there's areas where you need to dive even deeper. And for consulting, there's areas where you need to dive even deeper. Yes. I don't know if there's a good, easy way to put a number on it.
How did you get it? How long have you been doing it? How long, like when did you start semi-analysis?
I started semi-analysis 5 years ago, but I'd been doing a lot of this like for fun before that, right? So
Doing
when
what for fun?
when I had a job, well, just tracking everything that I could, right?
Okay.
I had a job, and I had my own job, not my own company, right? Or when I was in college, and I had internships and stuff, whatever money I would make, I would YOLO in the stock market on companies that I thought were interesting, right? So I would read all the earnings and all this stuff, right? But then also, even before that, I was always a tech enthusiast, right? So I moderated a bunch of forums online related to chips and AI and Android and smartphones and Apple and hardware, NVIDIA, AMD, Intel, like all these things I moderated and read constantly about. So I was a tech enthusiast, and I tried to understand everything about the tech. And then I was like, I started making money. I was like, I should also track the stocks. And that's a different viewpoint of angle, right? Like people who are tech enthusiasts don't necessarily read the earnings and like care about inventory dynamics, and like you kind of try and get at the problem in every way possible, and then that sort of gets you there. So I posted a lot anonymously as well, and then eventually I was fed up with the job that I had, and I stopped posting anonymously basically, and then all of a sudden started getting a lot more reach outs, because people are more willing to like reach out to someone who's like not anonymous than someone who's anonymous. And then I was like, oh wait, wow, there's consulting business here. Wait, why don't I just try and do this full time, because I hate my job? And then I quit my job. I started doing it full time, and then it was like successful. I kept gaining steam, and then I started hiring people who are experts in various verticals, people from hedge fund backgrounds to help organize and quantify data, right? And it sort of became this whole business. Yeah,
that's great. And so you started in earnest full time 5 years ago, approximately.
Yes.
And was there like this for you? Is there like this big vision for what you want this to be, or you're really just like, hey man, like I just like I've always loved this stuff. This is cool. And people are just gonna start paying me for it, and
Yeah.
I know it's gonna be a big thing, and so let's just keep doing it.
Yeah. I mean, I don't think the business model was really well thought out. It was just like it was like try and learn everything about everything, post some blogs and do some consulting, and like it was like, okay, this is cool. And then all of a sudden it started just gaining steam. It was like, let me, I hired a couple of people, and then like we started organizing data, and we started having data in some of the posts, and people are like, actually, I don't want a consulting, I just want to buy this data. And it's like, oh great, okay. And then it's like, wait, selling data is such a high value thing, right? Because consulting is like hours in, project out, right, 1-to-1. But data is like you've got a unique data set, you consult to 100 companies, right? And so that's sort of like the beauty of the data side of things is, and then that started gaining steam, and then we started like expanding. It's like, well, now there's like people who like have trained models and like program GPUs, all the way down to like people who have built ASML lithography tools, right? Like it's like, and we have like all this expertise across the stack, and all these different data products and all this different consulting. But I definitely never expected it to be this successful or broad. And now it's like, okay, I think other areas of focus like I haven't focused on historically, right? Like robotics, right?
Mm-hmm.
I have always focused on supply chain, but haven't focused on robotics. Now all of a sudden it's like, well, why don't we hire someone? Why don't we focus on just robotics? Why don't we take others in the team who have some peripheral understanding of supply chain elements, as well as this person who focuses only on robotics, and let's build something to track robotics, right? Whether it's supply chain, models, everything, right? And so that's sort of like what we're in the process of doing there, right? And there's a team that's working on that internally, right? It's like, so I didn't expect this to happen, but it's like, I want to know everything in the world. And then there's some way, everything in the AI infrastructure, semiconductor world, right? A data center world. And then there's some way to monetize it, of course, right? And so that's sort of like, as like what was successful worked out, right? It was like, we can monetize better in this way or that way, right? Or as business opportunities came and people approached, it was like very obvious that you can just do things and people will come and make money. And as long as you have all the information, there's ways to, and it can help people make their decisions better. You can make business, right?
Yeah, no, I mean, you're dealing with all types of markets that are are in the process of forming. So if you're helping to put structure and transparency at some level around those markets, it's the rest takes care of itself. It's kind of how I think
I mean, a
about it.
lot of
But
these markets have existed for decades, right? Like data
sure.
centers and
Oh, for
semiconductors,
sure.
right? Like, but it is fun to do it in a completely different way, right? Because it's not like there aren't market research firms and there aren't consulting firms in this space, right? But the average age of my firm is like 29, 28. That's how old I am as well. And like we have a lot of young people. We use a ton of AI in our process, right? Like we ingest. I don't know who else is ingesting all the regulatory filings around a certain radius of data centers through models, right? Who's using, who's that's like something like unique, right? And it's like, oh, there's so much information, whether it be SEC filings or permits or county level stuff, like all this other stuff that's being submitted. The information's there. You can auto submit FOIA requests, right? LLMs can just generate FOIA requests and then you can submit them, right? And then you get information, and then others don't even have that information, right? FOIA requests being Freedom of Information Act, right? There's all sorts of information that you can just like get. It's time consuming. It was extremely time consuming in the past. But if you can create the right data flows pipelines, whether it's through scraping data, transforming it, which is more historical, or using AI to ingest complex data like documents and extracting information out of it, or even generating things like FOIA requests, it's incredible like how much you can do now in an economic way because AI exists. And that sort of it's funny that like I don't think like the data center model that we have could exist without like we couldn't do the research process without the existence of all these models. And as the models get better, our research process gets better, and it makes the coverage of the data centers better, which is like driven by the fact that the models are getting better. So it's kind of funny.
Well, I mean, I think that's where my comment was when I was talking about these industries are just forming. Like, yes, many of them have been around for decades, but I guess I should rephrase. It's more of like the AI first version of the industries. I guess I would say seems like everything's being transformed. Different unit economics are being created. It's unclear, right? The economic value that's going to be created, everyone believes it's going to be pretty damn high, which which it will be. But yeah, so that's where that comment came from.
I don't know if everyone believes that. I think there's quite a few people who are like denialists. There's fear
Really?
and fear every day. Yeah.
Well, fear and denial is two different things. So unpack that for me.
So I would just say FUD as a general category, right? Fear, uncertainty, doubt. So there's a lot of fear that it's overbuilding, right? There's a lot of uncertainty that that there's this progress continues and there's actually demand for it and there's actually good use cases and like, oh, what's the real use of AI? Like you hear like these 50-year-old like bankers or whatever, like who's actually using AI? There's no revenue, and it's like literally ask your kid how AI is changing their life, right? So there's a lot of uncertainty of like actual use of it. Go talk to people in the software engineering industry and tell me that AI is not completely radically transforming it and dramatically reducing the cost of developing software, right? And then there's doubt, right? DeepSeek came out. Now all of a sudden you don't need all this stuff because it's so much more efficient. It's like, because it's more efficient, we'll use more, right? And we'll scale bigger and we'll make better, right? It's like this doubt. There is a class of contrarians who just hate, or rather like deny the progress. I think it's a reasonable like number of people too. It's less and less every day, but there are people who don't believe still.
Yeah, it's fascinating. I mean, it's so clear to me. It's clear as day that you have the two forces, right? The cost of the technologies will continue to plummet, and then just the percentage of budgets being allocated towards it and how they use it's just going to exponentially increase. It's like cloud, right? It's so obvious to me, and it's fascinating. There's such a big number of people, and you're closer to it than I am that don't like believe that or doubt that or something. It's pretty interesting. Seems pretty straightforward to me, but I don't know.
I mean, to be fair, right? The average person's life has not been affected by AI yet, right? I think for you and I, we can say there's all these ways I use AI, and there's all this change in my workflow, and hey, even like our businesses are predicated on people caring about AI, right? But I think a lot of people are like I go look at my dad and my mom. It's like my dad uses ChatGPT voice mode a little bit now, and that's an anomaly among people his age, right?
Sure.
And my mom doesn't use AI at all, right?
Yeah. No, I mean, I mean, for me, it's just kind of like it's the equivalent of like electricity. It's just going to power everything around us, literally everything. But I don't know, just my perspective. All right, so I think that's a good segue, Dylan, to because you're talking about um, the effect on the economy and how big of the effect is going to be to talk about the real world and robotics. So I want to move over to the report that originally caught my eye and how I came across semi-analysis. So I'm going to read a little excerpt, okay? I want to get your perspective on it. So this is the report, America is Missing the New Labor Economy, the robotics part one. And it reads this, which I think is pretty interesting. This is a call for action for the USA and the West. We are in the early precipice of a nonlinear transformation in industrial society, but the bedrock the US is standing on is shaky. At the moment, the West is caught flat footed. South Korea and Japan have a birth rate crisis that is throttling their manufacturing capabilities. European industrial sectors are being eaten alive by China in their inability to generate power. And the US is focused on other markets and procuring cheap overseas production. And all the while, China's manufacturing capacity has gotten stronger and robotics is catching fire. And then you go on, your team goes on to say China's on a clear path to full automation. Tell me why in your mind. I mean, do you think this is just, it's so far gone, the West has no chance? Just talk to me about what you're seeing on the ground today.
Right. So there's a lot of numbers in this post that we talk about, right? But one of them is just like, hey, what's the annual robot installations by country, right? Now, obviously, robots are simple. They're not humanoid robots. They could just be servo armed. They could be like, a lot of this stuff is used in factories and such, right?
Mm-hmm.
In 2014, China deployed roughly twice as many robots as Japan, USA, Korea, Germany individually, right? Each of these countries. You fast forward to 2023, and all four of these countries combined, right, are still a third of China's robot deployments, right? It is absurd, and this is this is like robots that are programmed, right? That, hey, pick this up, put it down, hey, screw this in, etc., right? Not robots that have actual AI that is sort of guiding them instead, like task based rather than like programming based. This is like, okay, great production, right? Manufacturing has always been cheap, right? But then when you go drill into this number deeper, right, it's how many robots are domestic versus foreign, right? And so even as near as 2022, the majority of China's robots were being imported, right? Japan and Germany being the largest market share players, but also USA, Korea is also in there, right? And so, but now in 2023, it flipped to be even. 24, it's rapidly growing Chinese share, and 25 it looks clear like the market shares is going to be 60. Is going to be like 70% Chinese robots for China's domestic usage, right? So these companies, they're not shrinking because the robot deployments, the foreign robotics companies, non-Chinese robotics companies, because the growth is so large. But there's huge numbers of robots that are being built, and then when you drill into the supply chain, it gets even more interesting, right? Two of Germany's best robotics companies were actually purchased by China, and a lot of their servos and actuator construction was actually transferred to China. And now those companies, and generally servers, actuators, all these different components, cooling fans, power supplies, all these different things are being manufactured in China and shipped to the foreign robotics companies who are then building it, right? So the base building blocks are not even being built domestically anywhere either, whether we're talking about the full-on robot or the partial component, right? And then so it becomes clear that like we can't manufacture robots in America at all. Germany and Japan are losing a lot of their capabilities to do so, / the cost of their robots are just way, way, way higher than what China can do. And so this becomes a really scary sort of thing in terms of, hey, what happens in these strategic industries? Whether it's rare earth minerals, basic metals like copper, lithium, cobalt, nickel, steel, graphite, manganese, aluminum, or you look at really complex things like EVs and consumer drones, China's market share is 50+%, in many cases 80+%, right? And these are the base building block for automation of the world around us, right? And so if the entire supply chain is there, right, how do you manufacture the end robot, right? Which, the whole pitch is like robots are, we're going to make a bunch of robots, and then robots are going to make robots, and then robots are going to, and those are going to build everything around us, and we can just like sit around with like VR headsets gooning or whatever, right? Like, it's fine. And so, the thing is, like, if you don't make the robots and you don't have the supply chain to make any of the subcomponents, the flywheel is not there, right? And that's the real worry, is that like the West is going to miss this. And we've seen this in many markets before, right? There's markets where China took over, right? Whether it be steel and aluminum and neodymium and copper and manganese and like a lot of rare earth minerals, where it was done externally and then it moved into China because of their cost. There's also markets where China was first, right? You definitely with drones and DJI, right? They made consumer drones a thing. And now you look at like drones across the world, and it's like, there's very little market share for other companies' drones / they cost 10x more, right? Versus a Chinese drone. And almost similar is happening to EVs, right? Yes, Tesla was first, and Vastus, but nowadays you look at BYD, you go look at their vehicles, it's absurd how fast they're scaling production, how much supply chain they have, how much lower cost they are than a Tesla, right? And Tesla's class leading. You go look at the other manufacturers and it's just a joke, right? And so when we look at this, like, it's not just like, it's more than just a robot, right? Robotics are a systems engineering problem with multiple machines. And if you can create that, then you can produce human work, right? But we can't make the robot, right? And I think that is or the supply chain for it. And I think that's a very concerning thing.
Yeah, it's interesting. I when I think about supply chain and I go, you go look up and down the stack, the thing that stood out to me, and I think if I were to boil one thing down in that report and you're writing, I want to get your perspective on this, is really this kind of processing and refining layer, because that's the real non-sexy, lower margin stuff that is really taken care of by industrial policy, where obviously China has made a decision on industrial policy the past 30, 40 years and is all in on it. And like, just from what you see, do you think the US and the West in general has the will to create an industrial policy to build these non-sexy industries so they can actually build their supply chain? Do we have no other choice? I mean, I don't know. Do you have a perspective on it?
The funny thing is, like, neodymium magnets, so scary, right? China makes all of them, right? We have like small efforts in the US, in the West, right? It's like, like a couple $100 million. There's one company now going to start making neodymium magnets, right? And neodymium magnets go into all sorts of stuff, right? We could just have as much capacity as China for a few $1 billion, right? A lot of these things, it is like, these are like, there's so many unsexy rare earth mineral sort of industries. There's dozens and dozens of them, and like the cost to replace it all domestically is not that high. The industrial policy, like, it is a dirty industry, right? Refining these things is really dirty. We would do it cleaner than China would, I would imagine, because it's just like, that's like, we care more about that. But generally, like, the cost to replace these things, after a one-time sort of like big CapEx surge would not be like that high, right? Now, obviously there's a lot with regards to, how would I say this? Continued cost deficit, and we probably would have a continued cost deficit. And so it's not economic. And industrial policy is all about like a surge of investment, and then it's able to sustain itself. And that's how China runs it as well. They have a huge surge of investment and then they pull back, right? Solar panels are not that subsidized anymore in China, right? They were historically. EVs are not that subsidized in China anymore, right? They were historically. These industries are built and they dominate the world globally, right? Whereas like, when you think about, hey, what if we do it here? What if we do all these various like rare earth minerals or magnets or whatever in America or in the West? One, we have to be okay with it being dirty, but two, we have to be okay with like supporting it for much longer because the industry is already there.
Sure. Do you think we have the will in the West to do it?
I hope we do. I don't know if we do, right? I don't think we do, right? It's a quite a concerning thing, right? If we don't have the will.
Yeah, man. I think there's this thing. I'm generally an optimist on this, and I just think there's this challenge you have, especially in the U.S., where I think people are just generally very short-term thinkers, partly because that's for whatever reason they have short-term needs or medium-term needs. It's very rare to meet someone that's a long-term thinker, and I think we need to change our culture around that in order to be able to do this. And so, I mean, I'm optimistic, but it's definitely an uphill battle. How
Well, the
how much
interesting
time do
thing
you?
is like
Okay.
when you look at the interesting thing is when you look at manufacturing, the way Western companies approach it and Chinese companies approach it is so different, right? When Western companies get a cost improvement, right? Oh, there's a new process. We improve the cost by 5%, 10%. They might pass on a couple percentage of the cost forward, but they'll increase their margins generally, right? Which is interesting. Whereas Chinese companies are almost all cost plus. They're not price to value; they're cost plus, right? And so you've got this interesting phenomenon where there are industries in China where the entire world relies on it. They could jack up the price, but they don't because their philosophy is so different, right? Their philosophy is if I reduce cost, I will reduce cost to the end customer, and that's just like the way they do it, right? And so like there's a constant decrease in cost. Like China's deflationary effect because of their manufacturing continues to happen because they keep reducing cost. And there's this pressure cooker of like our margins are here, and if they cut costs, they like cut the price. And so like margins are still here, and we need to reduce costs to like stay alive because what if like something happens, right? So there's like this constant pressure cooker of like continual cost reductions and engineering, and like it's not like oh well we make 80% margins, our cost is low, we charge a lot, like it's great, right? It's like because cost keeps going down, you've got this like increasing usage, right? But there's so many companies on the Hang Seng, which is a stock market in China, right? Whose stock has literally been flat or down, despite the fact that they own the global market, right? Like if there was a fucking Harvard Business School kid in charge of this, the company would make a ton of money for 5 years, and then they would have a competitor, and it would be destroyed, right? And it's like thankfully China's continued to export deflation. But the worry is like, what if they don't, right? What if they just all of a sudden stop one day?
Sure. No, it's an interesting point and a very important point where this kind of this cost plus mentality, which we definitely don't have in the US, that's for sure. How much time do you spend in the robotics space, like thinking or looking deeply at kind of the training side? Because obviously that's the big missing gap right now in training on real world data. Have you looked into that deeply or not as much yourself?
Yeah, so we've spent a lot of time getting in contact with the right people, right, to talk to them about this stuff, right? So whether it be researchers at Stanford and other major schools like CMU, right, Carnegie Mellon and Stanford and so on and so forth, where there's a lot of leading robotics researchers or leading companies, right? Pi and Skilled and Field and Gemini's robotics team or DeepMind's robotics, right? Like there's all these different places where people are progressing rapidly, and the model improvements are incredible, right? And you're starting to see generalization happen really fast. The challenge has been that there's not nearly as much data, right? But people have been working hard on that problem, and have been creating the flywheel.
Cool, man. Well, I appreciate it. I know we were cut a little short today on time, but we had some technical difficulties. But I appreciate it, man. It was a great initial conversation. I look forward to doing it again and getting into the weeds and some other stuff going forward.